Now I'm very excited to introduce our last speaker for today, and that is Victor. In case you're not familiar, Victor is also a Prisma ambassador, and today he's going to be talking about boosting development with Prisma and GraphQL. Victor is a senior full-stack engineer at DigitalOnUs by Tech Mahindra, where he helps lead the development of a product in the pharmaceutical industry. He loves working with TypeScript and Go, and he's one of the Prisma ambassadors. So now, without any further delay, I bring you Victor Iris. Victor, how's it going?
Hey, good. Thank you. All right,
Great.
so let's begin.
Let's begin. I see you've already shared your screen, and I don't want to take any time from your talk, so here it is. I give you the stage.
Thank you, Daniel. Okay, so this talk will be about how Prisma became a game changer for improving a challenging web application and how today that application has grown into a bigger enterprise platform. So as introduced earlier, I'm one of the Prisma ambassadors. I've been using Prisma since the beta version and have built a couple of applications for clients with it. I'm also a full stack engineer at DigitalOnUs. And we are a company that provide technology services to many corporations around the globe, especially providing cloud-based solutions. And before, I used to program a lot with PHP, but from a couple of years ago, I've transitioned more to TypeScript and Go. So those are my preferred languages right now. And in this project, the focus was to extend the features of a web application in the pharmaceutics area. So as you may imagine, when it comes to chemistry, there are a lot of aspects to consider, right? Data science is one of the things that help us automate this kind of thing so that big sets of data are managed easily. So for example, if there is a chemical compound, we could test for the reaction under certain circumstances, temperature, water, things like that. And it will be just painful to do all that by hand. So it's something that is automated usually with data science. And the problem, though, in the company was that all these scripts created by data science were manually changed according to the business case that was required. So the end user will come with a certain scenario he had to test, and another person from the lab will take the existing scripts appropriate for this case and run it and eventually respond to that end user with the results. So that's the reason why this application got created to enhance that process. The application allows users to create automation workflows using different Docker images for data science. So essentially, a user creates a combination of steps, and the application communicates the specific sequence and configuration of this sequence to other backend services that, after running, deliver the results straight to the end user without having to wait for another human to communicate. This improves the efficiency of the laboratories and definitely empowers users with endless possibilities, because now there are not just predefined business cases, but there are smaller pieces that they can change any way they want. Previously, the application was using a CMS for the backend with JavaScript and React in the frontend. But as the complexity of the workflow configurations continued to grow, we decided to transition the backend into a custom GraphQL API with Prisma. The first evident thing with this is that after figuring out the transition, the development cycles were way faster. New complex features were not only easily added, but they were also safe to add. Because the Prisma migrations now were able to transform the existing data models into new ones very easily. And that in the past would have added the risk of data loss or just increased the time of development, because we will have needed to create manually the scripts and take care of running those in each environment. The next huge advantage of Prisma in this project was the type safety. In the past, we sometimes will miss spelling errors during code review or deployment. And the CMS, as it was just using JavaScript, it will break during the runtime. No alert whatsoever was presented at build time. And with Prisma, all the CRUD operations, were strictly checked in both development and deployment time, giving a lot of confidence when adding new complex features. So we were able to move faster than before. Additionally, we implemented schema introspection in the front end, and all the types that were previously created by hand by the developers now are fully automated and always in sync with our data model. We even on the API expose the types that get generated by Prisma. So we reuse that across the logic, because as we have dependency injection, for example, in some of our functions, instead of declaring literally the type that we expect to pass to it and keep updating it, we have this central exposure of the Prisma type so that we can reuse that over our own logic. The most important models in the process of building a workflow with our automation tool are a component, which is an abstraction of a Docker container, let's say. So this component had information about how to create that Docker container. The workflow, which basically is a representation of a linked list of different components to be run. So users will have, as you see in the screen, will have the options A, B, and C, and those will be linked in a linear way. So the backend will create a template with this sequence and communicate it to like a task runner that we have behind scenes. So similar, as you can see in GitHub Actions or by using Jenkins, in there you define the different stages of your workflow. And in here, you just drag and drop different options that are already defined, and the backend will take care of generating the YAML using for the workflow execution. The component on workflow was another model behind scenes, and that was for connecting the components with workflow, but for storing the configurations of those components. But later on, the concept became more complex. Whoops. Okay. Later on, the workflow concept became more complex because a user could create branches for running multiple steps at the same time, or even take their outputs as the inputs of another step. And without the control of the data model, that would have been a headache to implement, because the CMS was preventing us from doing advanced relations. But Prisma made it easy by allowing us to define a step model, which is a new concept that takes the component on workflow and adds, among other things, a recursive relationship. In that way, workflows are more like a graph instead of a linked list, and that opens a whole set of new possibilities. With the step model in place, more exciting features were added, such as custom form inputs for configuring the step. So in the past, we had all these single input form that would allow values to be passed to your Docker container in execution. So you could pass different arguments, let's say, to a CLI that was running inside that container. And those things were always configured in the same way for all components. So if a new developer created a new component, they will have to follow the same rules and adapt their program to receive the data in the same way. So instead, with this customization that we added, we got rid of that standardization or that rigid input, let's say. And components became easier to develop due to the independence of their configuration. So we created an ARC model and that arg will be mapped to a version, and that version will be mapped to a component. So there was more granularity in terms of how a component could be configured. You could, for example, define dropdowns, file selectors, different kinds of things that wouldn't only provide more insight to the UI to know how to present the form, but would also help us determine how to build the YAML template better. One of the main challenges we had was dealing with the database recursive relationships, because even though Prisma made it easy to define the data model, it was hard to manipulate the graph between the front end and the back end. For example, in GraphQL response, there's a JSON format, and that can have as many levels of nesting as we want. But for performance reasons, the nesting must be limited from a declaration of the query. So we need to know beforehand how deep the JSON is going to be. And as we could not predict the complexity of a workflow, it will be impossible to define how nested a query of steps will be. To solve this, we created utils for transforming the workflow graph structure into a flat representation of steps. This is not only something that allows us to solve the issue in the front end, but also in the backend, because it allowed us to build a Prisma query nester that will take the list and create it in the same way the graph has defined it. So the way the nester tool works is by going through each item on the list of steps, and it checks for the parents that are being referenced in there. So the sorter takes those and makes sure that the item only shows up if the referenced items are already in the list. So in that way, it takes this flattened representation of a graph and makes sure that it's going to be possible to create it correctly. And then there's a recursive function that navigates through that list of steps, creating one by a time, and keeps recording the database IDs locally. So on every iteration, the nester checks the reference parents and takes the ID that we already know from the database and connects the current item to those. And this has helped tremendously as well for testing, because as we have used the seeder feature of Prisma, we use our utils to make sure that we always get a concise order of our workflow elements. And today, our application, it's already part of an enterprise platform that we are also developing for the client, where more interesting features are being added every day. And it's where Prisma is helping us contribute for a better tomorrow, definitely. Our plans for the future include optimizing the nester with transactions, because right now it's just doing it linearly. We also are going to adapt Prisma officially in the backend of our central platform, and then connect all these different services with a federation architecture, because we are using Apollo Server. So everything will be more organized. And we also want to support real-time changes in the workflow editor, because right now we have WebSockets implemented for knowing when a workflow is run, what's the status of each step, but we are missing some more enhancements in the way of what's going to happen when multiple users are editing the same workflow. We may want to do like Google Docs or something like that, where you can see who others are making changes and what changes are occurring at that time. So now I'm going to show you a quick demo of how it looks like. Okay, so it's going to be test. All right, so in here on the Can you see my screen?
Yep, we can see a screen. It's a bit messy now. Okay, it's been unshared now.
Can you see the screen now?
Yep, that seems to be working.
Okay, so in here we have these agents, which is where our editor is. And you can see in here that we can create different components. So basically, this is what I was talking about, the complexity of version, and then keeping track of different arguments so that eventually the user can configure the components. So these are just the dummy ones created by our seeder. I'm just gonna drag and drop it. And as you can see in here, it loads how the input should be for this component. So we have different things like drop-downs, text inputs, we have switches for Boolean values, we have a file selector. So these will be saved as part of our workflow. And we can add different steps to this. So let's say that maybe we are reading from S3 or from another source in the step A. And in the other ones, we might be doing some processing in there. Well, actually, this is going to be P1. Then these may connect with a single one. So after processing all our data, we may have some logic that stores this somewhere. Maybe it exports to a repository, or maybe to an S3 bucket in another place. So C1. And for the more we can complicate this by doing things like this. So we may not only combine these two as input of one step, but we may want to take the processing for the, so we may have another processing here for calculating something else. And then we can keep storing that or processing as much as we want. In fact, we can have multiple routes. Right now, I'm only having one. But this is a graph, so it allows any structure that you may imagine. So I'm going to save this. And as you can see, it's presented in the same order I created it. So that's thanks to the sorter that we implemented. Now, I'm not calling directly the backend service that is in charge of running, but it's going to simulate that call. So yeah. And we also have these logs features. So similar to GitHub Actions or how other services for deployment work, we get logs of what's going on during the deployment. And as you may have noticed, it is started with the loading status in here, and it propagated to the other steps. So this information is communicated from WebSockets directly, and that was that's being stored on our database with a cron job that we have running behind scenes. And connected to our Prisma instance, we have a hook that communicates this through the WebSocket. So that's how users get this information precisely. And all these lists as well in the backend is using the sorter tool that I was mentioning for flattening this complex structure. And yeah, that's basically it. Do you have any questions about it, the demo, Daniel?
Hey, sorry, I wasn't fully sure if you finished your talk. So, wow, that was quite
Oh, yeah.
fascinating just to follow along and sort of see how essentially you're using, essentially, if I understand correctly, you're using the Prisma schema as a way to really do complex modeling, like you're really modeling a graph here rather than, simple linked lists, and you're able to really like represent all of these relationships. Is that something that you can show us a little bit? Yeah, the Prisma schema. I'd love to sort of see that.
Sure. Yeah. So I
Essentially, this
was
is,
mentioning. Yeah. Sorry. Go ahead.
I see here already you have essentially, you're doing this using a self relation, and you have basically two self relations. It's a bit, it's a bit like the screen is a bit blurry. I'm not sure if it's on my end.
I see it well on the streaming preview.
Okay. Yeah, maybe you can walk us through how you model these graphs. I see that you have. Yeah, I'll let you do this.
Okay, thank you. Yeah, so as mentioned previously, there's the step model. So in here we have a self-recursive relationship, and we actually need both the parents and children's because we can request things in two ways, right? So we could at some point know what are the things before the current step and after the current step. So that's why we have this abstraction of parents and children, but they're basically pointing to the same relation on the database. And in here, to each of these steps, we have a different combination of arguments that are possible. So all these drop downs, text boxes, things like that are specified in here. So we can even make references across those arguments and do fancy things like not allowing a user to enter data in one of the inputs until one of the other arguments is configured. And also, when we submit a workflow and we detect in the backend that there was a required argument that has not a value, we reject that workflow immediately because otherwise it's going to break our generation of the template and it will fail unexpectedly when running it behind scenes.
Mm-hmm.
Yeah. So those are like the main models in here. And also we have things like templating. So if you have a certain configuration of your step that is using over and over, you can save that. So it will be like a snapshot, let's say, of your step, and that can be drag and drop in other places.
I see. Very nice. Is there anything else that you would like to share about this?
No, not really. So those are the main concepts in here about the project. Nonetheless, I would like to mention that as one of the Prisma ambassadors, I want to help the community to understand all these different complex things that you can achieve with Prisma. So I'll be releasing a free tutorial this week, I think. So just feel free to follow me on Twitter. And also, if you have any questions about Prisma, I will be really happy to help you.
So if you haven't already, Victor's Twitter is VictorIris_XYZ. Be sure to follow him. He's a Prisma ambassador. And yeah, I really look forward to checking out some of the articles that you're going to be writing.
Thank you, Daniel.
All right. So on that note, I think we're about to wrap up. Victor, thank you so much for presenting and for really walking us through, how you sort of like approach this problem and how you sort of modeled that using Prisma. That was quite interesting to see. And I hope that this serves the best of purposes in the pharmaceutics industry.
Thank you for inviting me. I think with Prisma, we can achieve amazing things for a better tomorrow.
Amen. So hope to see you soon, Victor. Thank you.